Hi students, in this video I will be discussing the lab program 7 for the subject data structures laboratory, and the subject code is BCS 305. Okay, so let's look at the problem statement. The statement is design, develop and implement a menu driven program in C for the following operations on a singly linked list. Okay, you have to implement singly linked list, and they have told it should be with respect to student data. The fields are USN, name, branch, and phone number. So your singly linked list, the node should be able to store all this information. The operations are create a singly linked list of n students, okay, using front insertion. You have to insert the elements from the front and display the status of singly linked list and count the number of nodes in it. So you have to display the contents and also count the number of nodes, and you have to perform insertion and deletion at the end of the singly linked list, and also perform insertion and deletion at the front of singly linked list. Okay, and you have to demonstrate how the singly linked list can be used as a stack and queue. Okay, let's go ahead. Now, before going to the lab program, first let us look at a linked list. Okay, a linked list is a linear data structure. Okay, that means the nodes are arranged one after the other. Okay, and each element is called as a node. So it's nothing but a series of nodes. Okay, and each node is divided into two parts. The first part is called as a data part. Okay, and the second part is called as a link part. So as you can see here, this is one node. Okay, it has two parts. One is your data part and the other part is your link part. Now, why is this data part anyways is used for storing the data? Okay, that you would give. Okay, and link part is specifically for storing the address of the next node. See, for example, in this one, in this node, okay, the link part will contain the address of the next node. For example, if the nodes look like this, okay, if the address of the first node is 100 and the second node is 200, okay, so here 200 will be stored because 200 is the address of the next node. What about the address over here? As you can see, there are no nodes after this node. So nothing will be stored, nothing as in null. Okay, this is about the the linked list. To be very precise, it's about the singly linked list. Okay, and they're used for creating trees or graphs. Okay, one of the applications. Now, some more points about it. They are dynamic in nature, so you can allocate the memory when required. That is, during runtime, you can allocate the memory. And also, insertion and deletion operations can be easily implemented using the on singly linked list. Okay, and they can be used for implementing stacks, queues, graphs, etc. Okay, linked list lets you insert the elements at the beginning and at the end of the list. So you can insert the elements at the beginning or at the end. Also, you can delete the elements from the front as well as at the end. Okay, so let's go ahead. So linked list are of different types. So quickly we'll see. This is a singly linked list. As you can see, this node contains the address of the next node. Okay, and this node, this is a second node. It will contain the address of the third node and so on. This is singly linked list. Okay. Now let's look at this next type, that is circular linked list. Circular as in circle. See, this is first node, this is second node, and this is third node. So this part, that is your link part, will contain the address of the second node. So the address of the second would be stored here. Okay, here address of the third node would be stored. Address of the third node. But what about here? If it was a singly linked list, this would have been null. But because this is not singly linked list, this is circular linked list. So here, instead of having null, this will be like a circle. So this will contain the information of your first node. Circular linked list is where the last node is pointing to the first node. That is circular linked list. Doubly linked list. See here. Okay. Usually node is made up of two parts, data part and the address part. Here, a node is divided into three parts. So the middle part is your info or the data part. Your left part is called as previous. And this one is your next, for example. And this next part will contain the address of the next node, whereas previous would contain the address of your previous node. For example, if I take nodes like this, so this particular node 2, okay, in that the previous part will contain the address of your previous node, as in the address of 1. And here it will contain the address of the next node being 3. Okay, like this. This is how the doubly linked list works. Okay, now we'll look at the algorithm. See, you have to implement the concept of singly linked list. So the steps of the algorithm are, first you have to start, then you have to read the values. Okay, you have to create the singly linked list, display the status, and count the number of the nodes, and perform the insertion at the front, and perform the insertion at the end. Also perform deletion at the front, deletion at the end. Okay, and demonstrate how the singly linked list can be used as a stack, and how is it also used as a queue. Then we finish the algorithm. This is the first part of the code. Okay, header file. You know what is the use of header file stdio.h? Do you know? If not, let me tell you. In our program, we have certain functions like printf and scanf. Okay, so the code or the function definition and the function, not the definition, sorry, the function for printf, the code is written in the, or it is present in the header file called as stdio.h. Standard library. Standard library can be used for various purposes. In this particular program, because we are using these keywords like return, exit, also we are using this dynamic memory allocation technique in this particular program. So if you want to carry out dynamic memory allocation, you should use this standard library function, header file, because dynamic memory allocation includes this malloc, calloc. If you're using malloc, calloc in your code, then the standard library function should be used. Okay. Now, this part specifically is for creating the node. If you remember, okay, this is my struct name, struct node, and if you, we can visualize it something like this. Okay, a node is made up of two parts, data part and the link part. Okay, data part and the link part. And here link means the link to the, or the address to the next node, whereas in the data part, your program statement says that it has to store the USN, it has to store the name, it has to store the branch, and also the phone number and SEM number. So what we are doing is, in the data part, we are storing all the information. So USN can be stored, then name can be stored, branch, your phone number, and your SEM. So all this comes together in the data part. This is your data part. And this one, unsigned long int, is because, you know, phone number, okay, usually is made up of 10 digits. So if you just make use of int, okay, int might not be able to store that many digits. So you can make use of long int. Okay. And this one is your link part. So link this part. See, I told you that link means the address. Okay, so it will store the address. So if I want to store an address, I can't make use of a normal variable. Instead, I should be making use of a pointer variable. So this one is for that pointer. But what is this? See, when you're storing the node, okay, when you're storing the link part, so link part will contain the address of the next node. So that is why it is a pointer. Now, if you know, I hope you remember that a pointer does not have a data type of its own. It will point, or it will take the data type of the value that it is pointing to. So here in this case, the pointer will store the address of the next node. So node information, okay, so it will take the address of that node itself. So that is why it goes like this. So you have to always remember, in the linked list declaration, I have done it like this. So um, struct node is your data type, struct node. Okay, and values are USN, name, branch, data, phone number, and SEM. This will be stored in your data part, and in your link part, the pointer or the address of the next node will be stored. Now I have made use of type def because I don't want to use this name. Okay, I don't want to use this keyword, that is this data type struct node. So instead of that, from now on, I will be using node. See, what is the use of this? Let me show you. See, this one. Okay, now if I have to denote a particular struct variable, then I will have to use like this struct node. Then I will have to write the variable name, something like this. So instead of writing such a lengthy name, if I make use of type def, so next time, instead of writing struct node, I can just make use of node. So instead of writing struct node s, I can just write node and then s. This is like an alias. Okay, like the second name. Okay, so not the name, this one is like the data type. So from now on, I will not be using struct node. Instead, I will be using just node. Okay, that is the alternate name that I have given. Okay, now some more variable declarations. See, temp is a variable, or when I want to insert a particular node, or whatever node I want to access right now, for that I have declared one variable called as temp. Okay, and first is equal to null. See, when you have a linked list like this, okay, so if the addresses are like this, so this will be 100 and this will be null. But what about the address of this first node? So we have one head, or first, we call it as first. You can also call this as head node, which will contain the address of the very first node. Which will contain the address of the very first node. So this would be 100. This particular node does not have any data type, it's just a pointer that will store the address of the first node. Okay, so this is your first part. Now, I have used temp. Okay, temp is my current node. Now I will try to allocate the memory. I will create that one. See here, get node function is called. Node is the data type. I will name the node as X. So in that, I will be creating a node called as X. So it will have data part and it will also have a link part. See here, X of link is null. So X's link is equal to null, which means that X is the only node. So it does not have any node before it, also before it and also after it. So this part will be null. So X of link is null, this part. What about the data part? I have to create the data part also, right? So I am using the technique of dynamic memory allocation. So I will give the data type malloc and I will give the size of operator. Because I want to create the nodes, so I will give the size of struct node. Okay, then I will return that particular name. This is how the get node function works. So I have also given the explanation. Take a moment. You can pause this particular video and then read the information. Okay. I hope you have paused. You have got the information. Let us move to the next part. Now read. Read function is called. Okay. We have created the node over here, get node. Now we will try to read the information or put the information into the node. So I am calling that get node function, okay, to the variable temp. So information is, one is your USN. USN is of the type string. So percentages and the variable name that I've given is temp of USN. So in the temp is my variable name or node name, sorry. So in that I will be creating one part called as temp of USN. Likewise, temp of name, temp of branch, and phone number and SEP. If you remember, phone number was of the type long int. So that is why the specifier is LLU. Okay. So by the end, your linked list data part. So it will have USN, then name, then branch, then phone number and SEM. Okay, so this function has to be called whenever you want to put any information into the node. That is your read function. I hope this part is also clear. Let me clear out the. Okay, so sorry. Take a moment and go through the information once. You can pause the video and read the information. I think you should be able to understand. Okay, let's go to the next part. So I would like to create, if you remember, the first insertion is at the beginning. Okay, so I am going to create the simply linked list. So see, the number of students can be many. So I will ask the user first for the number of students. So percentage D ampersand and of n. So for each student, okay, I will be reading the information. So for I equal to 1, I less than or equal to n, I plus plus. So you will be calling this read function. Okay, that means putting the data basically. Okay, and remember, okay, see, first when I try to insert, okay, at the beginning, okay, at the beginning there would be no elements, isn't it? So you have to check that condition. Whether your linked list was empty and whatever you're going to insert now, okay, is that the very first node in the list? So how do you check if the linked list is empty? See, if the linked list is empty, the head node or the first node should not contain anything. If the first node, pointer, if it does not contain anything, that means if it is equal to null, whatever you create temp node, that will become the first. I mean, the information of the address of the temp would be stored here. Okay. Otherwise, if it is not, let's assume there are some nodes like this. And this is the first one. And let's say the address of this is 100, address of this is 200. So like this. So this would contain 100 and this would contain 200 and this is going to contain null. Now, if I want to insert one node called as temp in between, or not in between, sorry, in the beginning. So understand this, okay, I want to insert a node over here. So the connection of this one has to break. See, this has to break. In turn, a connection has to be formed like this. And this has to point over here. So temps next or temps link, this part, temps link, okay, should be pointing at the first. So previously the connection was like this. Okay, so this would be the first one. Correct. Now what you have to do is you have to make the temp node point to the first. That means we are talking about this line. Temps next will contain first, and wherever the first was there, this line will break, and Now the first should be containing the address of the temp. Okay. So temp's link should contain first, and whatever temp you have, because you have inserted at the very beginning, that should be assigned to first. Okay. So that is how the front insertion takes place. Okay, so this is to check if your linked list is empty. If it is so, whatever you insert will be the very first node. If it is not the case, then you will have to carry out these two steps. Okay, so take a moment. Take a moment to read the information. Okay, let's go to the next part. Next part was to count. Remember how many you have created a linked list. So you have to count how many nodes are there, all those things. So I am calling the function called as, or not calling, I am writing a function called as display count. Initially count is equal to 1. Okay. Initially the count is equal to 1. Then first is given to temp C. Let's assume it is like this. Two cases are there. One, if your linked list is empty. Linked list is empty. One condition. One condition is what if there are some nodes already present. This one. Nodes are present. So two things are there. I am taking this first node, this first one, and making that as temp so that I can count. Okay, this is my temporary arrangement that I have made. Whatever first was there, this is my first node. So that will be temp also here. Okay, then we'll try to print the details. So if you remember, how do you check if the list is empty? If the list is empty, first is equal to null. Then you say that there is nothing to be displayed. So the count is 0. Otherwise, okay, see this part. See, I have to count. Okay, so I have to count like this. For this particular linked list, the count is 3 because there are 3 nodes, isn't it? Now, what I have done is initially I have taken the count as 1. I have already taken the count is equal to 1. And I have made my temp also point at the first node, and first is anyways this node. Now, how do I go and count? See, what I will do is, see, first I should count this one. Okay, first I will count this one. See, initially count is here. So first is equal to temp means this is already counted. Now I have to take the control from this node to this node. That means somehow I have to make the movement to here. I have to take the temp from here to here so that I can count it. See here, wherever the temp was pointing to. So temp of next or temp of link, wherever it is pointing to. Okay. Temp of link wherever it is pointing to, that means if it is if there is a valid value, that means next node is present. See, for example, here if this is 200 and if this address is 100 and this is 300. Okay, see, if this node has a next node, so that address part will not be null. Next time this will contain 300. Next time this will be null. This will be null, right? So if it is not equal to null, I have to go from this particular node to this node to this node. So how do I traverse? I go by using this condition. And when do I stop? When it is not, when it becomes equal. When the temp of next becomes equal, I stop. But if it is not, then I start counting. I will increase the count. That means I move to the next node. Not only doing that, I will display the contents also over here. Okay, the contents I will display. Also, I will make the temp as the next node as a temp. So, temp of link will now become the temp. Okay, when it is not equal to null. So, what happens here is when it is not equal to null. So, this will not be considered when it is not equal to null. So, here. Okay, let me erase a few things so that you are not getting confused. So, so first time this will be 1, then 2. See, when do I stop? When this is not equal to null. So I want to stop at the one node that is previous to the last node. So this is my last node. So I will stop over here. Okay. Because that is how I can move. Temp of link. I can't use this condition. See, temp of link is becoming temp. I can't do that because for the next one, for the last one, if I do that, there is no value. This statement will not be true. It will not be correct. So I am stopping at the one last node before the very last node. So before this, I'm stopping over here. Okay, so first will be there, then second will be there. First time when it will check, okay, whether temp of link is equal to null. Temp of link is equal to null for the first node. For the first node, it is not equal to null. So it will count. Okay, 1. Then it will come here. It will, because of the temp of link, because of this statement, it will come to this node. Then again, it will check whether it is equal to null. No, so this also will be counted. So count becomes 2. When it comes here, it is null, so it will stop. So we have finished the counting till here. So the control of the loop will come out of it, and then we will specifically, see here. And one more thing, see, count is equal to 1. For the last node, okay, see, this is for your last node, this count. Okay, so it will display the information of the count like this. Next, let me erase all the ink. Take some time and read the information. Now insert at the front. So this is probably the easiest. So, okay, you insert front. You details of the student, you will be using the read function that was written previously. That will be called. And if there is no node, then whatever you insert will become the very first node. Else will come to this condition. I'll write some nodes are already present, and this is your first. This one will be this will be containing the very first node's information address, and this will be 200, this will be none. Now I want to insert. Sorry. Now I want to insert a temp node in the beginning, insert at the front. So if I insert this temp node, so temp of next should be pointing at first because this is first. And now temp will become the very first. That is what is happening over here. Temp of link is first, and temp will be now assigned to first. Okay. Next, insert at the end. So it will be like this. Okay, again, insert at the end. So, okay, so here you see many logics are there. This is a logic I have used. So I'm taking last. Okay, see, this one is your first, right? This one is your first. This is your head node. So this will be your first node, correct? And okay, so like this will be the null last value. Now what happens is, again, you're trying to insert at the end. If it is empty, then whatever you insert becomes a very first node, that itself will become first. Otherwise, what we have to do is, I have to move to the end. I have to move to the end. That means I have to move here and then insert the temp over here. then insert the temp over here. But right now I only have first. I only have first. So how do I take the control from this node to this node and then insert another node? So I have this function. When last of link is not equal to null. Now, last of link is not equal to null. That means, okay, I will bring the control to this part. So it's here in this case, okay, last of link. So this is also your last, right? Because in this one, I have assigned first also this only, last also this only. Now I will try to move to the next node. So last of link, that means this one's link, whether it is having null. No, this is not equal to null because this contains the address of this node. Okay, so it will come here. It will try to get the control over here. Okay, but it will check here. See, whether the last of link is equal to null. Yes, it is. Okay, if it is so, then what should happen? Then what should happen? Your last of link should become the last one. So this last of link should become your last. Okay, so you're trying to insert one node. Last of link, sorry, there's only one connection. Sorry, 1 minute. So we are like this. Okay, so this is null. Okay, when it is not equal to null means we are here. Okay, this is also your last now. First also this only, last also this only. Now last of link. Last of link means this part. The last of link is here. Last of link will become last. Now this will become last. Okay. Now last of link, this line. Okay. Last of link will now point towards step. That is what is happening over here. And then we will return the first. Return the first. This is the logic. Next, delete from the front. So again, first will be the temp one. Okay, this is for your reference. If the first is equal to null, list is empty. Otherwise, you can see before I delete, I make sure that I am storing the information into or I'm displaying the information. So temp of USN is getting displayed to let the user know that that's the item that is getting deleted. And see like this. This is first. This is first, right? Now, if I delete this one, first of link wherever it is pointing to, that will become the new first. Okay. After that, you free the variable, the temp node, and you return. So the logic is you will have in nodes like this. Okay. So this will be pointed by first. Now I have to do the deletion from the front. That means I have to delete this node. See, this was previously the first node, right? Now wherever first was pointing to, so wherever first was pointing to means this part. First is pointing to this one, right? First is pointing to this one. So that has to become your first node. That means automatically this will get deleted. Okay. And read the information. Delete from the end. This is quite tricky, like how the insertion from the end took place. So what we have done is, I'll take one linked list into consideration. And I've also taken, see, I've taken the node last. Okay. I've taken one node called as last, and that will be containing null. Okay. Now, first is temp. So this will become your temp. Okay. Again, if the list is empty, nothing to be deleted. So we are saying list is empty. Else, if there is only one node in your list, so if the first of link First of link means this part. Okay, we'll take this as first. That is your temp. If this is equal to null, if I delete this, then your list will become empty. That is what it is saying. So if you delete that item, first will become null. Else, that means some nodes are already there. How do you delete? So this is first. This will be 100, 200, 300. This is null. This is 300. And this is 200. Now we have to go till the node that is before the last node. So we are talking about this one. So temp is not equal to null. Okay. We are taking this itself as the last. Okay. Temp is equal to last. So temp is here, right? Temp is also here. Then wherever temp of link is pointing to, that will make it as a new temp. Okay. Once it reaches to this, once it crosses this, that means once it is reaching here, whatever is to the next of it, that will get null. See, we will stop here. Okay. Because of this condition, we will stop here. Then what we will do is, this last is having some address, right? We will delete it off. We will make last of link as null. That means automatically this node will get deleted and will free the temp. Okay. So that is how it works. Okay. And main program. So void main choice while it is 1. Okay. So enter the choice. Different cases. 1 means create, 2 means display, 3 is insert, 4 means insert at the end, 5 means display front, display at the end, 7 means exit. Default means invalid choice. Okay. This is the information. So I hope you have understood the code. Thank you so much.